So this is Unit 9, Lesson 3, which is the next one after the previous one we did on law of sines. We're going to continue using law of sines today to look at something called the ambiguous case, which ambiguous means it's sort of unknown, we're unsure. And when we're talking about triangles, there's certain information that they can give us that doesn't ensure just one triangle. It could be maybe two possible options given that information, or maybe no triangles that could possibly have that information. So throughout this, we're going to, and I just noticed my printout is all messed up, so hopefully yours looks fine, but we're going to try to figure out how many triangles are possible within these situations using the law of sines. Okay, so in the first one, we are going to determine all possible values for the measure of angle C, it says. So angle C is right here, opposite this side of 10. 36 is opposite 6. So when I set up law of sines, I'm going to have 6 over sine 36 equals 10 over sine C. And when I cross multiply and solve, I end up getting sine C equals some ugly decimal number, 0.97964, etc. And then when you do the inverse sine, remember that from last lesson, you get 78.419, etc. So approximately 78 degrees. Now the thing is, we know that this angle has to be part of the triangle. We don't know if this angle here has to exactly be 78 degrees because this angle is a question. So we actually could use 78 degrees for that second angle, or the supplement of 78 degrees, which is 102. And within the ambiguous case, that's always what's going to happen. We're either going to use the angle we find or its supplement. We know that 36 degrees has to be part of the triangle. So now we have to ask ourselves, is there room for a third angle? Well, here, yeah, 66 would be 36, 78, there's 66 degrees left. So that triangle would work. 102 and 36 is 138, so that would leave you with 42 degrees, so that triangle works as well. So in this case, given this information, there would actually be two possible triangles that we could draw there. Or actually the question was asking for the possible measures for angle C, so it would be either 66 degrees or 42 degrees. We're going to talk more about the possible triangles in the next one. So let's look at number 2. Again, we have a triangle with some information given, and we want to find the possible values for angle B. So we have that side of 10, which is opposite angle B. Come on. So we're going to do, computer's really slowly scrolling the page down. Come on. I don't know, that's the best we're going to get. 10 over sine of B. Oh, what is happening? Now we've decided to go way far below. So let's come back. It's scrolled way too far now. We're like on the homework pages. Any day there, computer. Oh my gosh. So let's scroll down. Sorry about this. You may want to end up fast forwarding me when this actually happens so you don't waste time watching me try to scroll down on my page. Come on. All right, so I finally got that figured out. So we have 14 over sine 80 equals 10 over sine of B. 14 over sine 80 equals 10 over sine B. And again, you're going to end up having to cross multiply and solve, and within solving that, you're going to have to use inverse sine. But for angle B, you end up getting 44.703, etc., which is approximately 45 degrees. Now, we know that that 80-degree angle has to be part of the triangle because it was given to us. But the second angle, angle B, could be approximately 45 degrees, or it could be the supplement of 45 degrees, which is 135 degrees. Now, if we add 80 and 45, is there room for a third angle? Yeah, there's room for 55 degrees more. So that triangle works. If we had 80 and 135, we get 215, which has already passed the 180 degrees that we have for that triangle. So only one triangle would be possible. And the reason why, I kind of said there's no room left. Not really a fancy explanation, but there's kind of no room left. Okay. Let's look at number 3. Find all possible values for measure of angle C. So we're trying to find options for this. My laptop is really freaking out. I think this is going to have to be the last video I do for today because it is done. 18 over sine C equals 12 over sine 52. Again, cross multiply and solve. You end up getting sine C equals 1.182, etc. Because when you do 18 sine 52, and then you end up dividing that by 12, there's your, oh, am I in, oh no, I'm in radian mode. Let's get out of there. Let's try this again. 18 sine 52, I need to do all over again. And then divide that by 12. So there's your 1.182, etc. Now, if we try to do inverse sine of that, something interesting is going to happen. You're going to see an error. You guys should know why that error is there. Oh, man, come on. You should know why that error is there. The error is happening because we can't have a sine value greater than 1 or less than negative 1. Remember, your unit circle and your sine curve goes up to 1, down to negative 1, etc. So we end up getting an error. So how many possible values are there? There's none. There are no triangles possible in this problem given the information that they gave you. So let's go on to the next one. Hopefully my computer will go down to the next page nice and smooth, but, oh, okay. So we have to draw our own triangle here. In triangle DEF, doesn't matter where you put the letters, DEF, the measure of angle E is 72. The measure of DE is 12. DF is 15, and we want to see how many triangles are possible. So again, we've got this side, this angle, this side. We can find angle F. So 12 over sine F equals 15 over sine 72. You may want to pause me so that you can figure out the answer yourself. F ends up being 49.53, etc. So about 50 degrees. So we have the 72 degree angle given, blank and blank, blank and blank. So angle F could be about 50 degrees, or it could be 130. Is there room for a third angle here? Yes. Is there room for a third angle here? No, we're already at over 200 degrees. So how many triangles are possible? 1. Now, in number 5, when you do law of sines there, you end up getting, actually, in triangle ABC, let's draw this better, come on. A, B, C. AB is 10, BC is 10 square root of 3. Angle A is 60, so we could do 10 square root of 3 over sine 60 equals 10 over sine, sine of C. Come on. And when we cross multiply and solve there, we get angle C is 30 degrees, or could be 30 degrees. Let's set up our 3 lines, and I'm running out of space up there, so I'll do it down here. I know that that first angle has to be the 60 degree angle that's given. The next angle could be 30, or it could be the supplement of 30, which is 150. And then the last angle here, 60 and 30 is 90. That leaves you with 90 degrees. 60 and 150, no room left there. So this is the only triangle possible, but the question says, based on this, angle B is, and this is where we found angle B right here. Actually, no, that's not angle B. This is angle C, because we found angle C. So this was angle A that was given. This was angle C. Angle B has to be a right angle. Must be. There's no other options for it. Okay. Go down to number 7, or number 6, excuse me. So we've got this triangle given, and we want to find all possible areas for the triangle. So this has the extra extension of doing the area of the triangle as well. So let's erase this stuff here, get it out of my way. Come on. Computer's really hurting right now. Erase. So we've got this side and this angle. We've got this side so we can find that angle. So 13 over sine 40 equals 18 over sine D. When I cross multiply and solve, I end up getting angle D is approximately 62.82 degrees, so about 63 degrees. Let's set up our spaces for our possible angles here. So this is angle D, and then, actually no, angle B, which was given, which is 40 degrees. We just found angle D to be either 63 degrees or its supplement, which is 117. So does that leave us room for angle C? Yeah, it could be 77 degrees, or it could be 23 degrees. Now for the areas, we're going to have to figure out the two possible areas here. These are the only two sides that they gave us. So since those are the only two sides that they gave us, when you do area, 1/2 AB sine C, we have to use the angle between those two sides, which is angle C. But angle C could be 77 degrees, or it could be 23 degrees. Both times we're using 13 and 18 as the sides, but the angle between them could be 77 or it could be 23. And obviously both of those are going to yield different areas. It says round your answer to the nearest square inch. When you plug these in the calculator, you get 158 square inches for the first one, or 46 square inches for the second option. So because there were two options for angle C there, there's also two options for what the area of that triangle could be. All right, let's look at the last one. And actually, I don't want to stress the last one too much. It's kind of like an extension problem. But actually, we're at 12 minutes. We're going to skip that last one because it's kind of more of a challenge problem. We can look at it in class if you guys want. But this is what's called the ambiguous case. Allows us to figure out how many distinct different triangles we can find within a triangle when you're given certain information.